Welcome students. Myself, Assistant Professor Jeetendra Gurjar from KLS Gupta Institution of Technology, Belgavi. Today, I'm going to present few problems on inverse trigonometric functions. Here we start. So very important and very easily you can simplify this. After going through today's lecture, you easily simplify the problems which will be very helpful in your examination, students. So please write down the example 1. Find tan inverse C1x minus y divided by C1 y plus x plus tan inverse C2 minus C1 divided by 1 plus C1 C2 and so on. So this function continues, right? So in this type of example, you can see that many students they get afraid. Yes, you should not afraid. You should think wisely and simplify the problem very beautifully. So whenever this type of problems comes around, there will be four options. How you are going to choose? Use your mind. It should strike in your mind as already discussed in the previous lecture also. You are going to choose some value. Wherever such type of examples comes from, please see that you choose a particular value and just substitute. You find you will get definitely the answer. This is a very important trick and you have to remember, those who are appearing for the examination, you should always practice the trick. My advice, always practice the tricks are, you have to remember the tricks. In this example, very easily you should be able to identify the trick that just substitute the values. So directly you cannot simplify in inverse trigonometric function, very difficult to solve, but use the trick. Within 1 minute you should able to simplify. So here we go. C1 is equal to C2. You are going to choose 0. So in this example, you can easily find wherever C1, C2 is there, you can easily see as one. So here C1 is there, C2 is there, this is 0, right? And this will become again 0. So all these things with there doesn't exist. Only the first one will exist. So just substitute here. Easily you can see here. This is tan inverse. This is 0. So minus y will be there only, divided by C1. Again it is 0. So only x will remain here. This is x. Remaining all the terms will get cancelled because they're all at the same type. So all these terms will go on and the last term will remain, that is Cn will remain. So easily you can simplify the value. This is tan inverse 1 upon 0. So here you can simplify this one. So this you can easily simplify. This is tan inverse y upon x. So minus you can take outside, plus this is pi by 2. This is a trick you have to remember, okay? So now you just simplify. This is equal to. So another trick is that whenever they give in the series form, see that the first term and the last term is taken always. Always you have to remember first and the last term will be very important. Whatever you substitute, you just take this and add them. So therefore this is tan inverse is there. I can take pi by 2 here. So therefore this will become like cot inverse y upon x, right? So I want to easily can simplify this ones. So therefore this is now going to be, if we simplify, reverse this, tan inverse x by y, because I want tan. So therefore our answer is B. So you have to simplify like this form. So next question, please write down the value of tan. This is just trick. You have to understand the trick and simplify. That is more important. Understanding the problem and using the trick is very important. In 1 minute, you can easily simplify the problem. The value of tan inverse 2 cos 2 sine inverse 1 upon 2 is. So this is the options they have given: minus pi by 4, pi by 4, pi by 2, none of this. So you just simplify the problem, students. So here we take solution. How you simplify? Yes, first you take down the equation, whatever the equation they have given, write it down, right? So please remember what is sine inverse 1 upon 2. So it is 30 degrees, means pi by 6 we will get. So therefore the equation will become like this. So tan inverse This is 2 cos. 1 minute is more than enough, students. So 2 into this is pi by 6. So quickly you can simplify. This is tan inverse 2 cos. Yes, students. So see here you can see easily. So 2 and 3 it will become 2 1s are 2 3s are. So cos pi by 3 is 1 upon 2. Yes. So you can easily write like this. This is 1 upon 2. Okay. So again 2 2 will get cancelled, right? Within 1 minute easily you can simplify. This is tan inverse 1, which will give you this is pi by 4. So pi by 4, B is the answer. Yes, students, easily you can see the next one is very, very important. Find the solution of x. Here we have to find the value of x. Tan inverse x plus 1 upon x minus 1 plus cot inverse x upon x minus 1 is equal to tan inverse minus x. Minus 7, sorry. So they have given 4 options. Find the value of x, students. We have to find the value of x here. So please take down. This is, you have to find solution of x. So therefore 1 minute is more than enough, students. You can easily simplify. In such type of examples, make this tan here. This is x minus 1 upon x. Use a plus b. Tan a, tan inverse a plus tan inverse b. So just interchange x. This is going to become tan inverse x minus 1 divided by x. So use the formula, students. Easily you can see this is going to be, you remember the formulas, x plus 1 divided by x minus 1 plus x minus 1 upon x. Yes, please convert this in the tan form. Okay, so tan form, how you write? Tan inverse x minus 1 upon x. So then you use this formula. Okay, divided by, this is going to be 1 minus x plus 1 x minus 1 into x minus 1 upon x, which is equal to tan inverse minus 7. So easily you simplify. Take down the LCM in the numerator and in the denominator. You can see x minus 1 and x is in the numerator and x minus 1 x is in the denominator, will get cancelled. Take the LCM here, x into x minus 1 this side. So then this is x minus 1 into x minus 1. Here it is x minus x plus 1 into x plus x minus 1 the whole square. So just simplify, take down the LCM properly. So write down, you will get here x 2x square minus x plus 1 divided by minus x minus 1. So this will be equal to tan inverse minus 7. So go on simplifying, take here in, take, remove the tan inverse, take down only the inside the tan inverse. So therefore if you just simplify it, so you can see this is going to be 2x square minus x plus 1 is equal to, this is minus 7, take down here minus x minus 1, right? Simplify, x is equal to, you find it 2. So therefore the answer here is 2. Okay, students. Okay, fine. So go for the next example. Find the value of the following: tan inverse 1 plus cos inverse minus 1 upon 2 plus sine inverse minus 1 upon 2. The 4 options they have given. Easily you can simplify this one's solution. You can easily write here. So tan inverse 1 upon 2. You have to remember the formula. It is pi by 4 plus. Here you can see minus is there. So definitely if you take out the minus, so therefore this will be pi. Pi minus, this is cos 1 upon 2. Cos 1 upon 2 will be always pi upon 3. So because of this minus 1, this is very, very dangerous. You should be very careful while taking the minus. So therefore you'll get this minus, here this is pi by 6. So therefore this will be the simple trick. Use the angle. So just this is pi by 4 plus 2 pi by 3 minus pi by 6. So minus will be minus only, no change. So this will be 3 pi by 4. So option is B. Is it clear, friends? Okay. So like this you should able to simplify. If sine inverse x is equal to y, then yes, friends. Now anybody looking at the problem can see this is, you have to remember the property. So in the property it is clearly mentioned that whenever sine inverse exists, right? If sin inverse x exists, then using the principal value bond. So there is always a principal value bond, students. Please remember, sin inverse exists when there is pi by 2 to minus pi by 2. So therefore, we can easily find this is B. B is the answer. So now again go for the next example, students. Easily you can see, if x square plus y square plus z square is equal to r square, then find the value of, yes students, you can, this is type of examples will be very very important, and you can easily simplify this. Take down the solution, students. Just whenever they have given in this type, they would take a is equal to y upon z xr, b is equal to, so we can have to simplify this very easily, or then C. A, B, C, you just take students. It will make it very, very simple and very easily. Don't get afraid. So just substitute the values here. So in this function, so we can directly write like this. This equation can be written as, this is tan inverse A plus tan inverse B plus tan inverse C is equal to, you have to remember this formula, students. This is equal to tan inverse S1 minus S3 divided by 1 minus S2. This formula you have to remember, right? So when you substitute, you get back this answer. So therefore, what will be S2? S2, you have to remember, this is AB plus BC plus CA. This is a trick, you have to remember these two lines. So just substitute the values. So if you take A and B, just go on substituting here YZ upon XR, you'll find the answer. B is equal to, this is ZX upon YR. Just what I'm doing here, students, all the values I'm substituting, you have to remember this trick, and XY upon ZR plus C XY upon ZR into, this is A Y Z upon XR. So if you just simplify, it will be Z square upon R square. So you can see there is a cancellation, x get cancelled, right? So therefore here it will be x square upon r square plus y square upon r square. Just simplify, go on simplifying this one. So therefore this is equal to, you can easily write like this. So take down the LCM, x square plus y square plus z square upon r square. But what is r square? R square is given, x square plus y square plus z square, means this is S2 is equal to 1, right? So when S2 is equal to 1, therefore you can substitute in the equation, it will be tan inverse 1 upon S1 minus S3 upon 0, means this is tan inverse not defined, right? So tan inverse, we get here something here divided by 0 is always pi by 2. So therefore you can easily choose the answer here, pi by 2. So this answer you are going to get, this is equal to pi by 2. Is it clear, students? Okay. So next, very very important, and such type of examples are very regularly is asked in the exam. Okay, so please write down here. So this will be, find the value of summation n1 to infinity tan inverse 1 divided by n square plus n plus 1. So easily you can simplify. In this type of example, students, please remember, you go on substituting the value so that it will become in the series form. So take down summation n1 to infinity. This is tan inverse 1 divided by n square plus n plus 1 is equal to, this is tan inverse 1 upon 3 plus tan inverse. Go on substituting 1, 2, 3 value. Easily you will get this till infinity. But here you see, whenever such type of examples will come from, see that you modify this equation such a way that it should come in the tan inverse x minus y upon 1 plus xy. Means I have to make this tan inverse in this form, x minus y divided by 1 plus xy form. So always keep this in mind, friends. So therefore I write like this now. Suppose tan inverse This is 1 divided by, just modify this equation now, 1 plus n into n plus 1. What I have done, I have just taken n from this common, so this will be n into n plus 1. This I have written. So therefore this is equal to, just I'm modifying this equation, it should look like in this form. So just I will add and subtract n here. So this is n plus 1 minus n divided by 1 plus n plus 1. So this is of the form, yes students, you can see easily, x is here, n plus 1, y is n. So you can see this is of the form, right? Now you simplify this problem. So this is actually tan inverse a plus tan inverse b. So here minus is there, so you take tan a minus tan b. Very easily you can simplify this one. So here it is n plus 1 is there. So therefore I will take this is yes value, right? So therefore when we take the series, so series, we will take series is equal to, this is summation, this is series. If series is given, then n is equal to 1 to infinity. This will continue. So tan inverse n plus 1 minus tan inverse n. This series will continue. Okay. So whenever in the series, you have to remember, in the previous example I've discussed, the first term and the last term is always taken. Right. So here the last term will be what? It is n 1 to infinity. See, n is equal to 1 to dot dot n. So this is a trick you have to remember, that first term is 1, last term is infinity. So in tan inverse, you always take this infinity minus the first term. First term is tan inverse 1. So now easily you can simplify this one. This is a trick you have to remember. Tan inverse infinity is pi by 2 minus tan inverse 1 is pi by 4. So you can just simplify. You will get this is equal to pi by 4. So this is our answer. So this type of examples are very regularly asked in the examination. Yes friends, thank you so much for watching the video. Go again and again the videos, practice the videos, all the